The moment Lieutenant Commander Lawrence Randall Daspit watched through his periscope on July 24, 1943, would expose a weapon scandal so profound that it threatened America's entire Pacific naval strategy. 120 miles west of Truk Lagoon, a 19,262-ton Japanese tanker sat motionless in the water, its engines disabled by two perfectly placed torpedo strikes. The target was defenseless, enormous, and utterly vulnerable. What followed over the next hour would document the final and most devastating failure of America's primary submarine weapon, a failure that had been killing American submariners and prolonging the war for nearly 2 years. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Daspit positioned USS Tenosa for the textbook finishing attack. At 875 yards, directly abeam of the tanker, at a 90-degree angle, he had achieved the geometric perfection every submarine commander trained for. This was the ideal shot, the attack angle that guaranteed success according to every manual, every training exercise, every tactical doctrine the Navy had developed. He began firing his remaining torpedoes methodically, one after another, watching through the periscope as each weapon ran straight and true toward the massive target. The first torpedo struck the hull with a dull thud, no explosion. The second torpedo hit, no explosion. The third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and 11th torpedoes all struck the stationary tanker with sickening thuds. Not one exploded. 15 torpedoes fired in total. 11 confirmed hits from perfect range and angle. Only 2 explosions. A sitting target sailed away because American torpedoes simply refused to work. The Mark 14 torpedo had been designed as America's supreme naval weapon, a 20-foot 6-inch marvel of engineering carrying 643 pounds of high-explosive torpex. Each torpedo cost $10,000 in 1931 currency, equivalent to roughly $180,000 today, more than the price of 15 new automobiles. The weapon's true innovation lay in the Mark 6 magnetic influence exploder, developed in absolute secrecy, beginning in 1922. The magnetic exploder was designed to detonate beneath a ship's keel where armor was thinnest, creating a massive gas bubble that would literally break the ship's back. A single hit could theoretically sink a battleship. The Navy had been so confident in this revolutionary design that it conducted exactly 2 EC fire tests, both on May 26, 1926. The first test failed completely when the torpedo passed beneath the target without exploding. The second test succeeded, deliberately destroying the decommissioned submarine USS L8. Then, for 17 years, until December 1941, not a single additional live fire test was conducted. The reason was brutally simple. Torpedoes were extraordinarily expensive, and the Great Depression had strangled military budgets. Congress slashed Navy funding throughout the 1930s, while the Naval Torpedo Station at Newport employed 3,000 workers, running 3 shifts around the clock, yet still produced only 1.5 torpedoes per day. Production was so slow that torpedo shortages began before the war even started. By January 1938, unfilled torpedo orders amounted to $29 million. There was simply no money and no supply for a destructive testing. So, the Navy tested the Mark 14 using lightweight practice warheads that allowed the torpedoes to float when they ran out of fuel. The practice warheads were recovered, examined, and pronounced perfect. The magnetic exploder was tested in laboratory tanks of still water with flawless results. The Bureau of Ordnance declared the Mark 14 ready for war without ever discovering that weapons designed in laboratory conditions and tested with dummy warheads do not always work in combat. When war erupted on December 8, 1941, American submarines went into combat with supreme confidence in their weapons. Within days, that confidence began to shatter. On December the 24th, just 16 days into the war, Commander Tyrrell Dwight Jacobs in USS Sargo fired 8 torpedoes at 2 Japanese merchant ships and achieved 0 hits, 0 explosions. Jacobs was certain his fire control solution was perfect after pursuing one target for 57 minutes to ensure his calculations match-paced precisely before firing. Yet, 8 torpedoes produced nothing. A week earlier, USS Seawolf had reported that torpedoes were running deeper than their depth settings, with the commanding officer estimating the torpedoes passed 10 to 15 feet below the targets, too deep for the magnetic exploder to detect the ship's magnetic field and too deep for contact hits. The reports multiplied rapidly as USS Sargo reported the first premature explosion just 1 week after Pearl Harbor, when a torpedo exploded halfway to its target. USS Skipjack, USS Stingray, USS Sturgeon all sent the same message from every patrol area. The torpedoes were not working. They ran too deep, exploded prematurely, failed to explode at all, or, most terrifyingly, circled back toward their own submarines. By June 1942, American submarines had fired over 800 torpedoes in combat with an 80% failure rate. 8 out of every 10 torpedoes fired at the enemy either missed, malfunctioned, or failed to detonate. The mathematics were devastating. American submarines should have been destroying the Japanese merchant marine. Yet, Japanese convoys sailed largely unmolested, while American submariners risked their lives with weapons that didn't work. The submarine commanders knew something was fundamentally wrong and sent detailed reports to their superiors, documenting every attack, every malfunction, every failure. They requested investigations and demanded tests. The response from the Bureau of Ordnance was consistent and insulting. The problem was not the torpedoes, but the submarine commanders who were making poor approaches, miscalculating firing solutions, and failing to maintain the weapons properly. The Bureau had designed the Mark 14, and the Naval Torpedo Station had built it after 2 decades of engineering went into its development. The fault could not possibly lie with the weapon, so the fault must lie with the men using it. One man was listening to the submarine commanders. Rear Admiral Charles Andrews Lockwood had been born in Midland, Virginia on May 6, 1890, and graduated from the United States Naval Academy in 1912. His submarine career began in September 1914, when he reported to the tender USS Mohican for submarine training, and by December 1, 1914, he commanded USS A2, the Navy's second submarine. Lockwood had spent nearly 3 decades in submarines and understood the men who commanded them. He knew they were reporting genuine problems, because when submarine commanders with years of experience all reported the same failures, it meant something was genuinely wrong with the weapons. In May 1942, Lockwood came Commander Submarines Southwest Pacific Area, based in Fremantle, Australia, and immediately found himself dealing with the Mark 14 controversy. His submarine commanders were reporting catastrophic failure rates, while Japanese ships escaped and American submarines accomplished almost nothing despite taking enormous risks. Lockwood knew the Bureau of Ordnance would never authorize official testing because the torpedoes were too expensive and the supply too limited, but he also understood that sending men into combat with defective weapons was infinitely more expensive than testing. In June 1942, Lockwood did something unprecedented by ordering unauthorized tests of the Mark 14 torpedo against Bureau of Ordnance regulations without permission and at risk to his career. He was determined to find out if the torpedoes really ran deep. Captain James Fife, Lockwood's chief of staff, devised an ingeniously simple test by firing torpedoes through fishing nets suspended at known depths in Frenchman Bay near Albany, Australia. On June 20th, 1942, USS Skipjack fired a single torpedo with an exercise warhead from 850 yards. The torpedo was set for a depth of 10 feet and should have pierced the net at 10 feet, but instead ripped through the net at 25 feet, 15 feet deeper than the setting. The next day, Fife supervised 2 more test shots with both torpedoes running 11 feet deeper than set. The evidence was conclusive that the Mark 14 ran dangerously deep, Yet, when Lockwood immediately reported his findings to the Bureau of Ordnance, the response was swift and dismissive. No reliable conclusions could be drawn from Lockwood's tests because the fishing net method was not scientifically valid, and the submarine commanders must have trimmed the torpedoes improperly. Lockwood repeated the tests with 3 torpedoes set at 10 feet, cutting the net at 21 feet, 11 feet deeper than the setting. Yet still the Bureau of Ordnance refused to accept the evidence because their tests at Newport showed no depth problems, and the fault must lie with the submarine force. Admiral Ernest Joseph King, Chief of Naval Operations, had heard enough and was not a man to tolerate bureaucratic nonsense. He ordered the Bureau of Ordnance to conduct their own tests immediately. In July 1942, the Bureau finally tested the Mark 14 at Newport, and in August 1942, more than 8 months into the war, the Bureau of Ordnance officially admitted that the Mark 14 torpedo ran 11 feet deeper than set. The cause was a nested series of design flaws. During development, the torpedoes had been tested with lightweight exercise warheads, but when loaded with heavy combat warheads containing 680 pounds of explosive, the torpedoes naturally ran deeper. That was only part of the problem, because the depth control mechanism used a pressure sensor to measure water depth, and during testing, this sensor had been placed in the torpedo's conical tail section. At 46 knots, water flowing past the conical shape created a low-pressure area that the pressure sensor incorrectly interpreted as shallow depth, directing the torpedo to dive deeper. The faster the torpedo traveled, the deeper it ran. This problem could have been discovered with a single test using a full warhead, but that test was never conducted because torpedoes were too expensive to destroy. By August 1942, the depth problem was identified, and the Bureau of Ordnance issued new instructions for calibrating the depth mechanism. Submarine commanders began setting their torpedoes to run at 0 depth to compensate for the 11-foot error. The Navy believed the torpedo problem was solved, but it was not. With the torpedoes now running at the correct depth, a new problem emerged with premature explosions as torpedoes detonated before reaching their targets. The explosions occurred hundreds of yards short of Japanese ships as submarine commanders watched through their periscopes while torpedoes detonated harmlessly in open water. The magnetic exploder was firing too early. On April 9, 1943, Lieutenant Commander John A. Scott in USS Tunney found himself in a perfect attack position with 3 Japanese aircraft carriers at range of only 880 yards. Point-blank range for a submarine attack. Scott fired all 10 torpedo tubes and heard 7 explosions, but none of the carriers slowed or showed damage as all 3 continued at full speed. Intelligence analysis later revealed that all 7 torpedoes had exploded prematurely, with the magnetic exploder triggering too early and not one torpedo reaching its target. On April 10th, USS Pompon attacked Japanese aircraft carrier Shokaku with 6 torpedoes, with at least 3 exploding prematurely and the carrier remaining undamaged. On June 10th, USS Trigger fired 6 torpedoes at aircraft carrier Hio from 1,200 yards, with 1 missing cleanly, 1 exploding prematurely, 1 being a dud, and 2 hitting to cause minor damage, while the carrier survived and limped home. The pattern was undeniable, as the magnetic exploder was unreliable. On April 27, 1943, the Bureau of Ordnance finally admitted the Mark 6 exploder was susceptible to premature explosions at shallow depths and recommended disconnecting the magnetic feature in favor of contact shots, though even this admission came with conditions, as the Bureau wanted to increase the arming distance from 450 yards to 700 yards and wanted submarine commanders to fire only under specific conditions that would minimize premature explosions. Admiral King rejected the increased arming distance because 700 yards was unacceptable, as submarines needed to get close to their targets. King agreed with Lockwood that the magnetic exploder should be disabled. On June 24, 1943, Admiral Chester Nimitz ordered all submarines in the Pacific Fleet to deactivate the magnetic influence exploder and use only the contact exploder. 18 months into the war, the Navy finally admitted that the magnetic exploder was a failure. Even with the depth problem fixed and the magnetic exploder disabled, torpedoes were still failing, as submarine commanders now reported a third problem with duds, torpedoes that hit Japanese ships and failed to explode. This brings us back to Lieutenant Commander Lawrence Daspit in USS Tinosa on July 24, 1943. After firing 15 torpedoes, with 11 confirmed hits and only 2 explosions against a sitting target, Daspit had 1 torpedo remaining. He made a decision that would change naval history by saving that torpedo and bringing it back to Pearl Harbor for examination, rather than wasting it on a target that torpedoes apparently could not sink. USS Tinosa arrived at Pearl Harbor on August 4th, 1943, with Daspit going directly to Submarine Force Headquarters, where Rear Admiral Charles Lockwood, who had replaced Robert English as Commander Submarines Pacific in February 1943 following English's death in a plane crash, met him at the door. Lockwood had been expecting an angry tirade and later wrote that he expected a torrent of cuss words damning him. The Bureau of Ordnance's, the Newport Torpedo Station, and the base torpedo shop, noting he could not have blamed Daspit because 19,000-ton tankers do not grow on trees. He thought Daspit was so furious as to be practically speechless. But Daspit did not explode because he was beyond anger. He simply described what had happened with 15 torpedoes, 11 confirmed hits, 2 explosions, and a sitting target that sailed away because American torpedoes did not work. Telling and preparing this story took us a lot of time. So if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The single torpedo Tinosa had brought back was immediately taken to the submarine base torpedo shop, where technicians examined it thoroughly and found nothing wrong. The torpedo was in perfect working order and, according to every test, should have exploded on impact. Lockwood knew he could not wait for the Bureau of Ordnance to act, because they had denied the depth problem for months and denied the magnetic exploder problem for over a year. They would deny the dud problem until presented with evidence so overwhelming that denial became impossible. Lockwood decided to conduct his own investigation again without authorization, again against regulations, and again at risk to his career. He ordered his gunnery and torpedo officer, Commander Art Taylor, to organize live fire tests where they would fire actual combat torpedoes with full warheads under conditions that simulated real attacks. Lieutenant Commander Swede Mommsen joined the investigation. Mommsen was already legendary in the submarine force because in 1939 he had led the rescue of 33 men from the sunken submarine USS Squalus and had invented the Mommsen lung, a breathing device that saved countless lives. He understood mechanical systems, understood testing, and understood that the Mark 14 was killing American submariners. Taylor and Mommsen scoured charts of Hawaiian waters, looking for the perfect test location, where they needed sheer vertical cliffs that dropped straight into deep water with a sandy bottom where torpedoes could be recovered. They found the perfect spot on the coast of Kahului, a small, uninhabited island southwest of Maui. On August 31st, 1943, USS Muskelung fired 3 torpedoes with full warheads into the cliffs of Kahului. The first 2 torpedoes exploded, but the third did not. Mommsen personally dove into the water to examine the failed torpedo, which was broken in 2 pieces, with the warhead split open, but had not detonated. With extreme care, the crew hoisted the unexploded torpedo onto a barge and transported it to Pearl Harbor. After disconnecting the warhead, Mommsen and his technicians disassembled the exploder mechanism, and what they found was shocking. The firing pin had been released from its restraint, but had not traveled far enough along its guide rails to strike the primer cap with sufficient force to detonate the explosive. The impact of hitting the cliff at 46 knots had crushed the delicate mechanism. The faster and harder the torpedo hit, the more likely the firing pin would jam without triggering the explosion. A perfect 90-degree hit, the ideal attack angle that submarine commanders trained for, was the most likely to produce a dud. Mommsen, could not test his theory by firing more expensive warheads into cliffs, so Lockwood approved a different approach. Art Taylor supervised the construction of a test rig by acquiring a crane from the Pearl Harbor shipyard and filling dummy warheads with sand to match the weight of full explosives. Then, they dropped the warheads from a height of 90 feet onto a steel plate positioned at various angles, with 90 feet carefully calculated, so a warhead dropped from that height would strike the plate at the same velocity as a torpedo traveling at 46 knots. The results were devastating, because when warheads struck the plate at 90 degrees, the perfect perpendicular hit, 70%, failed to detonate. 7 out of 10 duds. When warheads struck at 45 degrees, a glancing blow, only 50% failed, meaning the oblique hits were twice as reliable as the perfect hits. The problem was obvious, as the Mark VI exploder's firing pin mechanism was too delicate, having been designed for slower torpedoes. The Mark III exploder, used in World War I torpedoes, had suffered from the same problem, where impact forces would drive the firing pin sideways in its guides, jamming it before it could strike the primer. The solution had been to install a stronger spring, but when the Mark VI exploder was developed in the 1920s, the designers ignored the lessons learned from the Mark III and created a mechanism that was even more delicate. The faster Mark XIV, traveling at 46 knots instead of 30, generated impact forces that the firing pin mechanism could not withstand. Every submarine commander had been trained that a 90-degree shot was the ideal attack, but the 90-degree shot was the most likely to produce a dud. The Navy had been teaching submariners to use the one attack angle that was most likely to fail. Lockwood immediately sent a message to all submarines in his command, instructing them not to fire at 90-degree angles, but to fire at oblique angles of 45 degrees or less. The order baffled submarine commanders because it contradicted everything they had been taught and made attacks more difficult, but it cut the dud rate in half. The message also served another purpose by proving to the Bureau of Ordnance that the problem was real, that submarine commanders were not incompetent, and that the torpedoes were defective. Lockwood knew the oblique shot order was only a temporary solution because the firing pin mechanism had to be redesigned, but the Bureau of Ordnance controlled all torpedo modifications and was not interested in admitting another failure. So, Lockwood took matters into his own hands by ordering the submarine tender USS Holland to begin manufacturing modified firing pins. The solution was elegant, as the original Mark VI exploder used a heavy steel firing pin block, and under high impact forces, this heavy block's inertia would cause the firing pin to jam. Lieutenant E.A. Johnson, under Taylor's supervision, designed a lighter firing pin block machined from aluminum alloy, with the aluminum coming from an unlikely source, propellers from Japanese aircraft shot down during the attack on the Pearl Harbor. The irony was not lost on the submariners, who were fixing American torpedoes using metal from Japanese planes. Johnson also developed an electrical firing switch as an alternative to the mechanical firing pin, and both solutions worked while being relatively simple to manufacture. On September 30th, 1943, USS Barb departed Pearl Harbor on patrol with 20 torpedoes, all equipped with the modified aluminum firing pins manufactured aboard USS Holland. The results were immediate and dramatic, as Barb's torpedoes worked out. By mid-October, Holland had produced enough modified firing pins for all submarines departing on patrol. Nearly 2 years into the war, the United States Navy finally had a working torpedo, and the transformation was immediate. In 1942, American submarines fired 1,442 torpedoes and achieved limited success, with post-war analysis by the Joint Army-Navy Assessment Committee revealing the actual results were 134 ships totaling 180,390 tons. The actual success rate was far lower than wartime estimates. In 1944, with working torpedoes, American submarines sank 492 ships, totaling 2,387,780 tons. In 1945, they sank 132 ships totaling 469,872 tons, with the lower numbers reflecting target scarcity after the successful campaign had devastated Japan's merchant marine. The Mark 14 torpedo, once fixed, became one of the most effective weapons of the Pacific War as American submarines sank 1,314 Japanese vessels, totaling 5.3 million tons. They destroyed 60% of Japan's merchant marine, strangled Japan's supply lines, sank 8 aircraft carriers, 1 battleship, and 11 cruisers, and accounted for 55% of all Japanese shipping losses. But this success came at a terrible cost because the submarine force suffered the highest casualty rate of any branch of the American military, with 22% of submariners who went on patrol never returning. 52 submarines were lost with all hands, and 3,505 officers and men died. Many of those deaths occurred in the first 2 years of the war when torpedoes did not work. How many submarines were lost because their torpedoes failed at critical moments? How many submariners died because they had to make multiple attacks on targets that should have been destroyed with the first salvo? How many Japanese ships escaped to sink American vessels because submarine torpedoes were duds? These questions haunted Lockwood for the rest of his life. In September 1943, after the torpedo problems were finally solved, Lockwood described it as V-Day in submarine warfare. From September 30th, 1943 onward, American submarines were truly effective weapons, but Lockwood never stopped thinking about what might have been. He later wrote that had the torpedoes been properly tested before the war, we would have entered combat with weapons that functioned, the war would have been shorter, and many lives would have been saved. The Bureau of Ordnance never officially apologized, though in their post-war analysis, they admitted that testing had been inadequate, acknowledged that production planning had been faulty, and conceded that torpedoes were designed for meticulous small-scale manufacture that could not be scaled up for war production. The Bureau's final report stated that even with the relatively meager funds available in time of peace, much of the work now being done after more than a year and a half of war could and should have been accomplished years ago, that the work was not accomplished during peace or earlier during the war, or, so far as the Bureau's records disclose, that no one either at the Bureau or at Newport apparently questioned the inadequacy of the design without such tests, shows a lack of practical appreciation of the problems involved, which is incompatible with the Bureau's high standards and reflects discredit upon both the Bureau of Ordnance and the Naval Torpedo Station Newport. The Chief of the Bureau therefore directs that, as a matter of permanent policy, no service torpedo device ever be adopted as standard until it has been tested under conditions simulating as nearly as possible those which will be encountered in battle. It was an extraordinary admission, but came too late for the submariners who had died with defective weapons. The torpedo scandal revealed fundamental flaws in how the Navy developed and tested weapons because cost considerations had overridden operational effectiveness. Secrecy had prevented the people who used weapons from understanding how they worked, and bureaucratic pride had delayed fixes for problems that field commanders identified within weeks of the war starting. The Bureau of Ordnance had spent 20 years developing a torpedo that did not work, refused to believe reports from the men who risked their lives using it, blamed submarine commanders for incompetence rather than admitting design flaws, and when the problems could no longer be denied, fought every fix, every modification, and every improvement. Charles Lockwood became the hero of this story, not because he was a brilliant engineer, but because he listened to his submarine commanders, trusted their expertise, risked his career to conduct unauthorized tests, bypassed bureaucratic channels when official channels failed, took personal responsibility for fixing weapons that were not his responsibility to fix, and, most importantly, refused to send men into combat with weapons he knew were defective. Lockwood's unauthorized investigation at Frenchman Bay in June 1942 proved the depth problem. His unauthorized tests at Kahulaway in August 1943 proved the dud problem. His unauthorized manufacturing operation aboard USS Holland in September 1943 provided the fix that finally gave American submariners working torpedoes. Every step violated regulations. Every decision risked court-martial. Every action challenged the authority of the Bureau of Ordnance, one of the most powerful organizations in the Navy. But Lockwood understood something that the Bureau did not. The purpose of weapons is to work. The purpose of tests is to find failures. The purpose of leadership is to fix problems, not to deny them. By war's end, Lockwood had been promoted to Vice Admiral and attended the surrender ceremony aboard USS Missouri on September 2nd, 1945. He stood among the senior Allied commanders who had defeated Japan, while his submarine force had sunk more Japanese shipping than all other forces combined. The Mark 14 torpedo had become one of the most feared weapons in the Pacific. The story of the Mark 14 torpedo scandal is ultimately a story about testing, or rather, the failure to test. In 1931, a new automobile cost $700, while the Mark 14 torpedo cost $10,000. The Navy decided that torpedoes were too expensive to destroy in testing, so they tested using lightweight dummy warheads, tested the magnetic exploder in laboratory tanks, conducted exactly 2 live fire tests in 1926, then sent the weapon to war. The cost of not testing was measured in failed attacks, lost submarines, dead submariners, and a war prolonged. By 1944, the United States was producing 150 Mark 14 torpedoes per day, with total wartime production exceeding 60,000 torpedoes. At $10,000 each in 1931 currency, that represents $600 million or $12 billion in today's money. How much would proper testing have cost? A few dozen torpedoes destroyed in realistic tests would have revealed the depth problem, the magnetic exploder problem, and the firing pin problem before the war began. The cost would have been perhaps $500,000 in 1931 money, less than the cost of a single submarine. Instead, the Navy fought the war for 2 years with defective weapons, while submarine commanders achieved roughly 20% success rates when they should have achieved 80% or better. Japanese merchant ships that should have been destroyed in 1942 continued operating until 1944, and every month those ships operated, they supplied Japanese forces. Every Japanese soldier who received supplies from those ships had the opportunity to kill American soldiers. Every Japanese aircraft that received fuel from those tankers had the opportunity to shoot down American pilots. The mathematics are sobering, because if American torpedoes had worked properly from December 1941, the submarine force could have achieved in 1 year what it actually took 3 years to accomplish. Japan's merchant marine would have been destroyed by 1943 instead of 1945. The war might have ended years earlier, and tens of thousands of lives might have been saved, all for the cost of proper testing, with 50 torpedoes destroyed in realistic tests in 1939 at a cost of $500,000 that would have saved billions of dollars and immeasurable lives. But the Bureau of Ordnance decided that testing was too expensive, and they were wrong, because not testing was far more expensive. Today, the torpedo scandal is studied at military academies as a cautionary tale, teaching several critical lessons. First, systems must be tested under realistic conditions, because laboratory tests and dummy warheads do not reveal how weapons perform in combat. Second, the people who use weapons must be involved in testing and development, since submarine commanders understood torpedo problems within weeks of the war starting, but were not consulted during development. Third, bureaucratic organizations must be willing to admit mistakes, as the Bureau of Ordnance spent 2 years denying problems that were obvious to everyone in the field. Fourth, secrecy can be counterproductive, because the magnetic exploder was so secret that even submarine commanders were forbidden to examine it, which prevented the people who understood the weapon best from identifying its flaws. Fifth, leadership means listening, trusting expertise, and taking risks to fix problems, with Lockwood demonstrating that real leadership means challenging authority when authority is wrong, and refusing to send people into danger with equipment you know is defective. By September 1943, American submarines finally had working torpedoes, and the transformation was immediate, as submarine commanders who had endured 2 years of failures finally had weapons they could trust. USS Tang, under Commander Richard O'Kane, achieved remarkable success, while USS Barb, equipped with the modified firing pins from USS Holland, began a legendary combat record. American submarines patrolled the sea lanes around Japan, the Philippine Sea, the East China Sea, and the South China Sea, destroying tankers, freighters, troop ships, and warships. Japan's war economy ground to a halt as raw materials from the conquered territories could no longer reach the home islands. Oil from the Dutch East Indies, rubber from Malaya, and food from Indochina all had to travel by sea, and American submarines with working torpedoes controlled the seas. By 1945, Japan was strangled as her industries had no raw materials, her cities had no food, and her military had no fuel. American submarines had accomplished what strategic bombing and surface naval battles could not by destroying Japan's ability to continue the war, and they had done it with a weapon that, when it finally worked, was devastating. The Mark 14 torpedo remained in service until 1980, being upgraded, modified, and improved over the decades, but it never would have become the effective weapon it was without Charles Lockwood's impossible investigation. One admiral who refused to accept defective weapons, one investigation conducted against orders, one test that proved what everyone already knew, that the torpedoes did not work, and one decision to fix them, regardless of regulations, regardless of bureaucracy, and regardless of risk. Charles Lockwood died on June 6, 1967, at age 77, and is buried at Golden Gate National Cemetery in San Bruno, California, alongside Admirals Chester Nimitz, Raymond Spruance, and Richmond Kelly Turner, all heroes of the Pacific War and all leaders who transformed defeat into victory. But Lockwood's greatest victory was not won in the combat, but in the investigation at Frenchman Bay, in the tests at Kahului, in the manufacturing aboard USS Holland, in conference rooms in Washington, where he challenged the Bureau of Ordnance, in every patrol briefing where he listened to submarine commanders, and in every decision to trust his people over bureaucracy. Admiral Charles Lockwood's legacy is not found merely in the number of enemy ships sunk under his authority, nor in the tactical brilliance attributed to the silent service of the Pacific. His true legacy is a lesson, one carved out of frustration, defiance, and an unshakable responsibility to the men he commanded. It is the lesson that leadership sometimes means standing alone against the very system you serve. It means having the courage to challenge authority when lives depend on it, conducting the investigation everyone insists cannot be done, fixing the problems that everyone else claims do not exist, listening to your sailors when the bureaucracy refuses to, and, above all, refusing to send anyone into combat with weapons you truly know, are broken. During the first year of the Pacific War, American submarines operated under a curse that no amount of bravery, initiative, or tactical brilliance could overcome. The Mark 14 torpedo and its Mark 6 magnetic exploder. On paper, these weapons were the most advanced torpedoes in the world. They promised reliable magnetic detonations beneath a ship's keel, depth keeping so precise it could skim the ocean floor, and contact pistols that would function at any angle. For 2 decades, the Bureau of Ordnance swore by them. For 2 decades, the Bureau forbade live-fire tests because the torpedo was considered too expensive to expend. And for 2 decades, no one questioned that logic. Then, the war came, and suddenly, those untested assumptions were being tested in real combat by real crews whose lives depended on each launch. The result was a catastrophe hidden under layers of bureaucratic pride and willful blindness. Torpedoes ran too deep. The magnetic exploders detonated prematurely or not at all. The contact pistols failed on anything like a perpendicular hit. Submarine commanders risked their lives to line up perfect attacks, only to watch their perfect weapons bounce off enemy hulls like blunt sticks or detonate hundreds of yards early. giving away their positions. Reports poured in from commanders, duds, premature explosions, depth errors. Yet every protest that reached the Bureau of Ordnance was dismissed. The problem, they insisted, was not with the weapons, but with the crews. The torpedoes were flawless, the Bureau said. The men firing them, combat veterans with years of training, were not. It was an excuse that cost lives. It was a lie that prolonged a war. And this was the system Charles "Uncle Charlie" Lockwood walked into when he took command of submarine forces in the Pacific. He inherited gallant crews armed with unreliable weapons, a front line drowning in failure reports, and a bureaucracy in Washington determined to protect its own pride at any cost. Lockwood was not a man easily intimidated, but he was also not reckless. He first did what good leaders do. He listened. He listened to the skippers who had risked everything to bring back evidence. He listened to the chiefs and torpedo men who had watched their launches malfunction. He listened to the men who whispered their fears that the weapon meant to keep them alive might instead betray them. What he heard was undeniable. What the Bureau refused to see, Lockwood saw plainly. The torpedo was the problem, not the men. But to challenge Washington required proof, and proof required tests that the Bureau had refused to conduct for 20 years. Lockwood's impossible investigation began with the same question his sub-captains had been asking since the start of the war. Why does the Mark 14 not work? To answer it, Lockwood needed torpedoes, fired under controlled conditions, against real targets, not theoretical assumptions or desk-bound assurances. So he broke rules. He ordered tests the Bureau said could not be done. Expended torpedoes the Bureau said were too expensive to waste, and risked his career to expose what the bureaucracy would not admit. The first test shocked even him. A Mark 14 set to run at 10 feet pass beneath a target net at more than 20 feet. The torpedo's depth mechanism was catastrophically wrong. The Bureau had never properly tested it. Ever. They had calibrated the depth sensor against static pressure tanks, never understanding that water flow over a moving torpedo altered the dynamic pressure enough to fool the instrument. The torpedo had been running far too deep in every combat launch. Lockwood reported the results. Washington resisted. Lockwood tested again. Washington tried to suppress the findings. Lockwood insisted. Finally, the Bureau conceded and ordered depth adjustments across the fleet. It was a start, but only a start. The magnetic exploder remained a menace. Submarine crews reported premature detonations so frequently that commanders began disabling the magnetic feature on their own authority. The Bureau called this insubordination. Lockwood called it survival. He authorized his captains to deactivate the magnetic pistol entirely, defying explicit orders from Washington. Only after months of further failures, and after Lockwood's personal intervention, did the Bureau finally suspend the magnetic exploder. That left the contact pistol, the final point of betrayal. Captains soon reported a new nightmare: torpedoes that hit the enemy ship perfectly and simply failed to explode. Lockwood, infuriated, ordered additional tests. The results were damning. When striking at high angles, the firing pin in the contact pistol bent instead of triggering detonation. The mechanism was physically incapable of performing as designed at typical combat angles. Again, Lockwood confronted Washington. Again, resistance. But this time, armed with his tests, his evidence, and the suffering of his men, Lockwood forced the Bureau's hand. The contact pistol was redesigned. Live fire tests finally became mandatory, and slowly, painfully, the Mark 14 became the weapon it had always been advertised to be. Once fixed, the transformation was immediate and devastating. In just 18 months, American submarines sank more than 1,300 Japanese ships, strangling the nation's maritime lifelines and crippling its war economy. Merchant fleets vanished, oil convoys disappeared, industrial production collapsed. Japan, an island empire dependent on vast import flows, slowly suffocated. Historians estimate that the corrected torpedo program shortened the war by years. The price of not fixing it earlier is impossible to calculate, but the cost of the fix itself was minuscule. A handful of torpedoes used in proper testing, a few weeks of honest engineering, a willingness to admit fallibility. These were the expenses the Bureau of Ordnance refused to pay, and their refusal stretched the war, cost thousands of American and Allied lives, and allowed Japanese forces to operate with impunity long after they should have been hunted down. It was Lockwood's refusal to accept this negligence that changed everything. He demonstrated that real leadership is more than wearing rank or holding authority. Leadership is moral courage. It is the willingness to confront uncomfortable truths when those truths mean the difference between life and death. It is the ability to recognize that bureaucracy, left unchecked, becomes its own enemy. And it is the unyielding belief that the welfare of your people comes before the preservation of institutional pride. Lockwood's story echoes through every corner of military history. It serves as a warning to every engineer, every officer, every decision-maker, tempted to assume that what has always worked will continue to work, or that a weapon untested is somehow a weapon proven. It reminds us that the most expensive thing a military can do is refuse to test what it thinks it already understands. The cost of testing is measured in dollars. The cost of not testing is measured in lives, in lost battles, in wars, prolonged by years. In the end, Charles Lockwood did more than fix a torpedo. He forced a reckoning. He proved that no weapon, no system, and no authority is beyond question when the lives of one's people are at stake. He left behind a legacy etched not in steel or statistics, but in the safety of every submarine crew that followed him, and in the hard-earned truth that rigorous testing, honest assessment, and the courage to confront failure are not luxuries in wartime. They are necessities. And that is how one admiral's impossible investigation changed the course of the Pacific War. Up next, we have 2 more incredible stories that are waiting for you. Just click the image you want to watch and it will take you there. If you enjoyed this video, make sure to subscribe. It would mean a lot.